Hi, this video is about Cramer's rule, and we are applying determinants to solve systems of equation. We are concentrating on 3 by 3 metrics for simultaneous equations in 3 variables. We have done the 2 by 2 matrix already, so if you have not watched that video, kindly watch for deeper understanding. Revision of determinants of a 3 by 3 matrix. Given a 3 by 3 matrix with entries A, B, C, D, E, F, G, H, I, we first alternate plus, minus, and plus. And so we cross out the first column and first row. In fact, first row in each case, but we keep alternating the columns. So when you cross out the first row and first column, A has been double crossed. So A comes out and we are left with E, F, H, and I still to find the 2 by 2 determinant. Now minus B, because of the alternating of the plus, minus, and plus. Now when we cross out the first row and second column, B has been double crossed, so B comes out. And we have D, F, G, I to be found the 2 by 2 determinant in the next step. Then when we cross first row and third column, we have C out. C has been double crossed, so C comes out, and we have D, E, G, H still to work the determinant. In this case, 2 by 2 determinant. That is one method. Shall we look at another method? Another method shows that you have to repeat the first 2 columns. So A, D, G has been repeated after the line. Then B, E, H has also been repeated. So we find the leading diagonals. One of the leading diagonals is A multiplied by E multiplied by I. The second leading diagonal, B, F, G, we multiply them. Then the third leading diagonal, C, D, H, we multiply them. So the leading diagonals, we multiply them and sum them. Now the other diagonals, G, E, C, we multiply H, F, A, and I, D, B. Other diagonals, we multiply them and we sum them. Now Cramer's rule for 3 by 3 continues. Given a linear system, we have X column to be A1, A2, A3. The Y column is B1, B2, B3, and the Z column is C1, C2, C3. The constant column is D1, D2, D3. Let's assign names for each matrix. We have original determinant, which is A1, B1, C1, A2, B2, C2, A3, B3, C3. Then we have determinant of X, where X column has been replaced with the constant column. Then we have determinant of Y, where Y column has been replaced with the constant column. And determinant of Z, where Z column has been replaced with the constant column. Cramer's rule continues. To solve for the variable X, we have determinant of X over original determinant. That has been illustrated nicely over there. To To solve for the variable y, we have determinant of y over original determinant, also illustrated nicely. Then to solve for the variable z, we have determinant of z over original determinant, also illustrated very well. Cramer's rule for 3 by 3 matrix continuous. Now let's solve this system of equation. 2x plus y minus 2z equal to 7. Negative 2x plus z equal to negative 5. X plus 3y plus 4z equal to 10. The first step, we extract coefficients, and the coefficients are 2, 1, minus 2, minus 2, 0, 1, 1, 3, 4. Don't forget, in the second equation, there is no term in y, and so we have 0 in the middle. Very good. The next step is to calculate the original determinant D of matrix. Now, to calculate the original determinant, we repeat the first two columns. So you can see 2 minus 2, 1. 102, 103 has been repeated. Then we consider leading diagonals. 2 times 0 times 4, then 1 times 1 times 1. Then negative 2 times negative 2 times 3. Then when we multiply 2 times 0 times 4, we get 0. 1 times 1 times 1, we get 1. Then negative 2 times negative 2 times 3, we get 12. When we add, we get 13. Then other diagonals, we multiply other diagonals, and so we have 1 times 0 times negative 2 plus 1 times 2 plus 4 times negative 2 times 1. And so we have 0 plus 6 plus negative 8. When we add, we get negative 2. So to get our original determinant, we multiply and add all the leading diagonals, which we got 13. Then we subtract the other diagonals, which we got negative 2. So our original determinant is 13 minus negative 2, giving us 13 plus 2, and so 15. Well done. Now let's solve for x. We replace the first column of the coefficient matrix with the constant column. Then we calculate the determinant of the new matrix and divide by the original determinant, which is 15. And so you see, the first column has been replaced with the constant matrix, with the coefficient matrix. Then to solve for the determinant of x, we repeat the first two columns. So 7, negative 5, 10, 1, 0, 3 has been repeated after the line. So we multiply the leading diagonals. Very good. Then we multiply the other diagonals too. And so the leading diagonals gave us 7 times 0 times 4. That is 0 plus 1 times 1 times 10. That is 10. Plus negative 2 times negative 5 times 3. That is 30. So when we add, we get 40. And the other diagonals give us 10 times 0 times negative 2 plus 3 times 1 times 7 plus 4 times negative 5 times 1. When we add our results, we get 1. And so determinant of x is 40 minus 1, giving us 39. So to get our x is determinant of x over original determinant, which is 39. Determinant of x is 39 and original determinant is 15. So our x is 2.6. Nice. To solve for our y, we replace the second column of coefficient matrix with the constant matrix. Then we calculate the determinant of the new matrix and divide by the original determinant, which is 15. And so we replace the y column with the constant column. And so the y column has been replaced with the constant column. So we have the resulting matrix. So to solve the determinant, we repeat the first two columns. Now let's see our leading diagonals. We multiply our leading diagonals. Then we multiply our other diagonals. And so our leading diagonals give us 2 times negative 5 times 4 plus 7 times 1 times 1 plus minus 2 times minus 2 times 10. And when we add, we get 7. And our other diagonals give us 1 times minus 5 times minus 2 plus 10 times 1 times 2 plus 4 times minus 2 times 7. And so when we add, we get minus 26. So to finalize our determinant of y, we get all the products of the leading diagonals that gave us 7, and the products of the other diagonals we multiplied and we added also gave us negative 26. And so 7 minus negative 26 gave us 7 plus 26, which is 33. And so y is the same as determinant of y over original determinant. And our determinant of y is 33. Original determinant gave us 15. So our final answer is 2.2. Then we need to look for z. So we replace the third column of the coefficient matrix with the constant matrix, which is the constant column. Then we calculate the determinant of the new matrix and divide by the original determinant. So we replace the z column with the constant column. Then to solve for our determinant, we repeat the first two columns. Then we multiply our leading diagonals, 2 times 0 times 10, then 1 times minus 5 times 1, then 7 times minus 2 times 3. Then other diagonals, 1 times 0 times 7, 3 times 5 times 2 plus 10 times minus 2 times 1. So when we multiply and we add our results, we get negative 47. Now the other diagonals give us 0 plus negative 30 plus negative 20, also give us negative 50. So when we subtract leading minus other diagonal, we get negative 47 minus negative 50, resulting The result is 3. So to look for our z, is determinant of z over original determinant, which is 3 over 5. When we solve, we get 0.2. Thank you. God bless you.